Hey, what's up, guys? This is Chung here. So, 1775 equal sum arrays with minimum number of operations. So you're given like two arrays of integers, nums1 and nums2, and the only possible numbers uh, is from 1 to 6. And in one operations, you can change any integer's values in any of the arrays to any number between 1 to 6. And you need to return the minimum number of operations required to make the sum of values nums1 equals to the sum of nums2. Okay, and return -1 if it's not possible to do it. So for example, right, we have nums1 and nums2 here. So the answer for this one is 3 because basically, so the total for nums1 is what? It's so we have 1 plus 6 times 6 divided by 2. I think that's 21, right? So nums2 is what? It's what? Like it's 10. Okay, so which means that we either need to bring this nums1 down or increase this nums2 up, right? And example 2 here, right? So this is a -1 because the sum for nums1 is 7, right? And the sums of nums2 is 6. And there's no way you can bring the 7 down or bring the 6 up, right? So none of this works. That's why the answer is -1. And so for this one, it's also like it's also 3, right? So because we need to bring this 6 down, right, to some numbers, and then we can increase this 1 up to some numbers. That's why we have 3 here. I mean, since this one asks us to find the minimum numbers here, so for minimum numbers, we can always try to use greedy, because for this problem, otherwise, we can try to use binary search or even the BFS or DP. But for this problem, I think it's kind of obvious that this one is a greedy approach because mm, whenever we try to bring a nums down or up, right? So let's say we try to bring this nums1 down, we should always try to use the biggest number in this nums1 here because bring this nums6 down, right? It means that we can decrease nums by 5, right? And similarly, when we try to bring another nums array up, we should always try to use the numbers who is the smallest. For example, this one up, because this one can also give us like a 5 difference. So basically, the logic is that we get the total 1, we get total 1, and total 2, right? So that if we do a subtract between those two numbers, we will have like a difference, right? And basically, that difference is the one that we are trying to accomplish, right? By either bringing some numbers up or some numbers down. And we want to do it in a greedy way, so that we can finish. We can basically get this difference as soon as possible, which means the minimum number of operations. So which means that we need to sort. We need to basically try to do a sortings, right? Do a sortings like in such a way that by the by the difference that this number can obtain. For example, if we're trying to bring this up, so 1 will give us 5 difference, 2 will give us 4 difference, right? So the difference will be 6 minus num. that will be the difference if we try to bring the current numbers up, right? So similarly, when we try to bring some numbers down, the difference will be num minus 1, right? So this is the difference we can get if we try to make this bring this number down, right? Because let's say for 2, it's 1, right? So if we try to bring 2 down, because the minimum we can get is 1. That's why we do a minus 1, we'll get the difference. So if we do a transform of either nums1 or nums2 based on the total numbers here, right? Because if the for the total who is bigger, we'll basically we'll use this one, right? So the bigger numbers we need to bring them down. That's the nums minus 1, and for the totals who is smaller, we're gonna use this one to do the transform. And after that, we can just simply do a sort, because, or we can use a priority queue. But for this problem, the total time complexity will not change, because even though we use a priority queue, the worst case scenario, we will need to store all the numbers into this priority queue, right? So which means it's also n log n in this case, assuming n is the total length of the nums1 plus nums2. And basically, by using the priority queue or simply sort the combined transformed array here, the time complexity will be the same, which is n log n. And then we just do it in a way that, by always picking the biggest number, right? And then we try to decrease, use the number to decrease the difference until the difference either equals to 0 or smaller than 0, and that will be our final answer, right? Cool. So let's start coding here. So like I said, we need a total 1 here, and then going to be the sum of the nums1, right? And total 2 going to be the sum of the nums2 here. Sum. And if total 1 is smaller than total 2, right? It means that we need to increase nums1, which means that, for nums1, the difference will be 6 minus num, right? For num in nums2. And so for the other one, it's going to be this one, right? So nums minus 1 for num in nums2, right? So on the other side, right, we just need to basically copy and paste this thing here and change that, the operator here. So this one, we're going to be nums minus 1, and this one going to be the 6 minus num, right? And after this one, I just simply do a sort, basically sort this one from the reverse order. Reverse equals to true, right? Because I want to pick the numbers, the difference, right? The difference from the biggest to the smallest. And then we have difference, right? So difference will be ABS of the total 1 minus total 2. And we have n equals to length of the nums, right? And then we have I equals to 0. So basically, I do this while difference is greater than 0, right? Oh, we also need the answer here, equal to 0, right? If the difference and I is smaller than n, right? Actually, I can do this actually. So for I in range of n, right? We loop through this one here. Difference, right? Difference will be decreased by the nums of I. Okay, and every time we do this, we increase the operations by 1, right? And then if the difference is equal smaller than 0, right, we can simply break, right? And then we return the answer if difference is equal smaller than 0, else minus 1, right? Because we need to do this check, because it's possible that we cannot decrease that even after going through all the transformed arrays here. The difference are still not decrease enough to become 0. That's when we need to return -1, right? So I think that's it. If I run the code here, yeah. Ah, 2 3 0. Oh, I see. Mm. Mm. If difference 0, okay. Yeah, I can just do a. Yeah, I guess I can just do a simple check here because I'm assuming, right, difference is not 0. Okay. Yeah, so it passed, right? Yeah, so as you guys can see here, right? So since we have this kind of sort here, so it's going to be unlock n, right? You can also use priority queue, and whenever you finish one of the process here, you can just add it, right? You can add it, push it to the priority queue. But like I said, total time complexity will be the same. And also here, since we sort from the biggest to smallest, right? And then basically if the nums of I is equal to 0, right? So if this thing is 0, we can also break. That's a little bit of the early break, the early termination here, because if the current one is 0, it means that the remainings are all 0, which means that there's no need to continue, right? But this will not, this will not affect the total time complexity. It's just like a little bit of the early termination here, but yeah. Anyway, that's it. Yeah, I think that's everything for this problem. It's kind of uh, it's kind of obvious greedy problem, and you just need to do some a little bit transformation. And other than that, I think there's nothing else I want to talk about. Okay, I'll just stop here. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.